Okay, it's time for another word problem. This time we have three forces to deal with. They do give us a diagram, however we have to label it based on the information provided here in the problem itself. So we got 9.3 pound picture, 9.73 pound picture is hung from two wires, A and B, as shown there. And let's take a look at the first piece of information. It says the tension on A is 3.4 pounds at 161 degrees. Okay, well, this angle right here is A, that's measured from the positive x-axis. This is 161 degrees. That's the first angle that it's talking about there. You always have to make sure it's measured from the positive x-axis. Now the tension on that is 3.4 pounds. That's going to be, I'll put 3.4 there on that one. Now for B, the tension is 9.2 pounds, but it's at 69.59. That's 69.55 is the one on that. And the tension on that one is 9.2 pounds. I'm just going to go ahead and put equals 9.2 for the magnitude on B. And then for part C, it's 9.73 pounds, but it's negative 90. That's going to be straight down here. And this down here is 9.73 going down that way. So now we have the diagram is labeled properly. We have everything, all the pieces provided for us. Now let's break these up into components. For force A, that's going to be 3.4, that's going to be cosine 161I, and 3.4 sine 161, that's going to be J. So that's A written out, broken up into components. Now B, that's going to be 9.2, that's cosine 69.55 degrees I, and 9.2 sine 69.55 degrees J. So we have that one. Then for C, we have 9.73 cosine negative 90 I and 9.73 sine negative 90 J. So that's all the three angles broken up into components based on what was originally provided for us in the word problem itself, and we used our diagram here as a guide for labeling all those. Now what you want to do is you have to actually turn all these into decimals. Now we're going to add them all together, and that will allow us to find our magnitude and the direction. Let's go ahead and do that. For A, if we go ahead and write this out as decimals, that's negative 3.21I plus 1.11J, rounding everything to two decimal places. For B, we're going to do the same thing. That's 3.21 positive plus 8.62, and that's going to be J. If we change that into decimals, and then the bottom one, if we do that, we get 0, because cosine negative 90 down there, that's the x-coordinate, that would be 0. And then you have minus 9.73 J. So that is all three of our forces turned into decimals. Now what happens is an interesting thing here. When you add everything all together, you're actually going to get everything to cancel out. Your A plus B plus C, that's your resultant vector, you actually get 0 and you get 0. Okay, so we end up with a force with nothing. So when you get something that happens where you get 0 for both components, this actually has a special name, and this is called static equilibrium. And that's that one right there. So static equilibrium happens when you have zeros for both of those. So if I wanted to try to find the magnitude and direction for each one, since I don't actually have a force, both of those would end up being 0. I have 0 pounds at 0 degrees basically, and that would make sense because if you're hanging a picture on the wall, it's not going to be moving, it's going to be still, it's going to be static. So that's a case where if everything cancels out, you have what's called static equilibrium. Now for those of you that may be going on to engineering, one course that you take in engineering, if you go on, is called statics, and statics means that you actually study all different kinds of systems where you have something that's at rest. Now what you might do different in a class like that is maybe they would tell you first of all that everything does add up to 0, but you want to find out what are the tensions on the actual wires that will produce a force resulting in 0. And in that case you'd have to actually set up some systems equations and you would solve it that way, which we're not really going to be doing in this class. But that's the kind of problems that you would see in that type of statics class. So again, it is possible that you could have everything adding up to 0. In this case, we have no motion.